Guys, today we are going to discuss one of the important concepts from the security standpoint, that is HMAC authentication. So, what are the things that we are going to discuss in security? We have already discussed this password hashing and encryption. Today we are going to discuss HMAC, which is one of the most important security concepts that what you need to understand. So, let us proceed and understand what is HMAC, why we need HMAC, how HMAC authentication works. Then we also discuss right how to implement HMAC in our ASP.NET Core Web API. We'll also create the client application to test the endpoint with HMAC authentication. And we are also going to discuss for what purpose we are introducing HMAC, whether that purpose is solved or not. That what we are also going to test some negative scenarios. So let us proceed and understand this concept in detail. So what is HMAC? So HMAC means it stands, first of all, HMAC stands for Hash-Based Message Authentication Code. So it is a security mechanism which is basically used to implement, or you can say which is used to verify the authenticity and the integrity of a request. So basically, for example, if I'm sending a request, or you can say the client is sending a request to the server is going to verify whether that request or whatever the data sent by the client is correct data or not, whether the request is being coming from the appropriate client or not, whether the data is tampered by someone else in the middle or not. If it is a reply attack means the same request I have already served, again the same request is coming. So these kind of things are going to be handled by this HMAC in ASP.NET Core Web API, or you can take into consider any Web API application you take into consideration. This concept is not specific to ASP.NET Core, it is available in all the technology. So here we need to understand two things. What is a hash-based and what is message authentication code? So once you understand this hash-based and message authentication code, then we will see how it is going to be work in our real-time applications. So what is message authentication code? So basically, this is a short piece of information, or you can say this message authentication code is nothing but a simple, or you can say some piece of code which is used to confirm that a message was not altered. That means while transferring over the network from client to the server, this message, whatever the client is sending, it is not altered by someone in the middle, and this message is coming from the expected client. That means it is not coming from a attacker, it is coming from the expected client. Then what is this hash based? See, this is one of the code. This is message authentication code which we are going to generate. But how that code is going to be generated? For generating that code, we are going to use some kind of a hash function. Like you can use SHA-256, SHA-512, MD5. So any of this hashing technology you can use to generate this message authentication code. Once you generate this message authentication code, that code you need to send as part of your HTTP request from client to the server. But here one important thing that what you need to remember, while you are generating this message authentication code using this hash function, you have to use a secret key. You have to use a secret key, and moreover, that secret key needs to be shared between client and the server. That means server will generate the secret key. The server will share that secret key with the client. Client will use that secret key to generate the message authentication code. Once the message authentication code is generated, then that secret, then that message authentication code is going to be sent from the client to the server. Why that key is going to be shared between client and the server? That what we will also discuss, right? When we discuss how the message authentication, is going to work internally. Is that clear? What is HMAC? HMAC stands for Hash-Based Message Authentication Code. It is a security mechanism used to verify the integrity and authenticity of a message exchange between a client and a server. Clear?
Yes, sir.
Yes.
Right. So if someone asks you why we need to use message authentication code or HMAC, you have to tell, right? So basically, in a typical ASP.NET Core Web API, or you can say RESTful services, the data is going to be transferred between the client and the server. So in order to verify that the data, whatever transfer, is not altered by someone in the middle, to verify whether the request is coming from the genuine user or genuine client, we need to use HMAC authentication. So let us proceed and understand how the HMAC authentication work in our ASP.NET Core WebAPI application. So see guys, remember this is not specific to ASP.NET Core WebAPI. It is a right standard. Standard means it is available in almost all the technologies like ASP.NET, ASP.NET Core, like Java, Python, PHP. Everywhere this concept is available. So let us try to understand this step by step. Guys, remember this is very interesting, and please try to observe the things very clear. First of all, so to generate the message authentication code, we need a shared secret key. So who is going to generate that secret key? It is the responsibility of the web server to generate the secret key. Once it generates, that secret key needs to be stored in some secure channel, like in the database, and then that secret key will be shared to the client. That means the server going to generate a unique secret key for each client. For example, if you are developing some kind of a RESTful services, then there might be multiple client one, client two. For example, if you take the example of payment gateway. So payment gateway, let assume builders having the payment gateway. Now you want to consume builders payment gateway in your application. In that case, builders is the server. You are the client. Similarly, like you, there are 1,000 clients are there. They are using the payment gateway. So in that case, that builders, that is the server, going to generate a secret key for each client. Clear or not?
Yes.
Right? So
Yes.
once the server generates the secret key, that secret key will be shared with the client. That means now the client will store the secret key in some secured mechanism. The server also store that secret key in the secured mechanism. The client will get not only the secret key, what is its client ID, that is also received from the server. The server will generate a unique secret key, unique client ID for each client. That client ID and the client secret both are going to be shared between the client and the server. So now the client wants to send a request to the server. Then how that request is going to be sent, let us try to understand. So first of all, in HMAC authentication code, what we need to do, we need to generate one HMAC code. Then how that code is going to be generated? What are the content that we need to put inside the code? Let us try to understand. So in that case, the message authentication code, in order to generate, you have to use something called message. That message is nothing but you can consider that message is nothing but what is the HTTP method, whether it is a get request, post request, whichever endpoint you are going to consume. What type of a method is that? Post, put, get, patch, delete, whatever. Second, what is the URL path? How, right? What is the endpoint URL? How you are going to consume that resource? Third is what is the request body? If it is a get request or it is a right, get request means nobody, delete request means nobody. But if it is a post request or a put request, then in that case we have the body. So this message is nothing but your HTTP path, any custom HTTP path, the method type, and the request body. The secret key, definitely you should have the secret key which you received from the server. Hash function means any, right, how you are going to generate the HMAC, right? I mean, what hashing algorithm you want to implement? SHA 256, SHA 512, MD5, right? Whatever the algorithm. This timestamp, what is this timestamp? I will explain in detail. This is nothing but your Unix time. Unix time, or you can say epoch time. Does anyone having any idea what is Unix time or epoch time?
Is it the current time in seconds?
No, yes, current time in second, but that the time is going to be calculated based on the 1970. From 1970 till date, how many seconds are there? That integer, or you can say that long number, is nothing but your timestamp. So then nonce is nothing but it is a random unique generated number. For each request, this nonce is going to be generated once. Right? That means for each request, one unique random number, mostly it is going to be GUID. So message, secret key, hash function, timestamp, nonce. These five things are required to generate the HMAC. So what is the importance of this timestamp and nonce? So we understand message, the data is required. We understand the secret key which is used by the hash function to generate the HMAC. But what is the use of this timestamp and nonce? So these are the two things which is going to handle the reply attack. So these two things are going to handle the reply attack. So what is reply attack? How these two things are going to handle this thing, right? We will see practically. So now once you have this thing, then what you need to do, you have to use the HMAC algorithm. So whatever the algorithm you need to use, SAR 256 mostly we are going to use. So using that algorithm, we'll generate one HMAC message. Clear? So 1, 2, 3, step 3 means we are having that message authentication code. So once we have the message authentication code, then what we need to do, we need to send the actual HTTP request to the server. But while sending the actual HTTP request to the server, that HMAC header we need to set. This HMAC header going to contain 4 information. What are the information? First of all, what is the client ID? We are not going to share the secret key. We are going to share the client ID. Then what is the message authentication code we have generated? The third one is what is the timestamp we use to generate the HMAC. The fourth thing is nonce. What is the nonce we use to generate the HMAC code? So why we are passing this timestamp, nonce and client ID? Because server doesn't know who is the client sending the request. So we have to send the client ID. Based on the client ID, the server will check whether this client exists. If it exists, what is the corresponding secret key? Then why we are sending this timestamp and nonce? Because at the server end, we also need to generate the HMAC. And once you generate the HMAC, we will compare whatever the HMAC sent by the client and whatever the HMAC generated by the server. If both are matched or not. If both are matched, means what? The authentication is successful, the request can proceed. If not, then from there we will return some invalid error. So now once this step 4 is completed, you send a request to the server. Then the server receives the HTTP request from the client. So once the server receives the request, then what the server next is going to do? It is going to generate again the HMAC. The HMAC it is going to generate using the same HMAC algorithm, using the same data. So whatever data the client uses, whatever algorithm the client uses, generate the HMAC, the same things are going to be done by the server. Otherwise, the HMAC will not same. So whatever data I am using to generate the same data, the server needs to use to generate the HMAC along with the same algorithm, same secret key. So how it is going to do? First of all, whatever the message body, that what we will retrieve from the request body. From the request, we will get the request method type. From the request, we will get the URL path. From the request, we will also get the request body. Then secret key. That means what? Now, whenever the client sends the HMAC header, that HMAC header is composed of 4 things. What are the things? Client ID, HMAC code, nonce, and a timestamp. So based on the client ID, the server will retrieve the corresponding secret key from the server. Definitely, as a server, we need to tell, right, to the client what HMAC functions to be used. The same HMAC function we will use here also. And that HMAC header also contain the timestamp and nonce. Same timestamp and nonce will fetch from the HMAC order. That means the server now having the same data which is used by the client to generate the HMAC. So once we have the same data, then we'll use the same HMAC algorithm and we'll generate the HMAC again. So once we generate the HMAC, then we will compare the what is right this generated HMAC with the HMAC sent by the client. If both are same, request is valid, else it is invalid. Clear or not? Anyone having any question, they can ask me now.
Yes, Pranaya. One thing, when we are sending the request, we are generating the timestamp and nonce. But when server is also generating this HMAC, at that time, this timestamp and the nonce would be bit different than the
No,
the
no, no, no.
request, right?
First of all, you just tell. So what I'm saying now, okay, let me show you this thing practically, right? So whenever I'm sending the HMAC, right, that header is going to contain this thing, HMAC client ID, whatever your HMAC signature, nonce and the time. So this is the
Right.
request that what sent by the client. That means the
Yes.
client already storing this a nonce and the timestamp or not,
Yes.
right? What I have written here. So from where this timestamp and nonce the server will retrieve.
Okay, it is received from header. Okay, I
So
didn't check
HMAC
it.
header. So from here, whatever the nonce and the timestamp client use, the same thing is also going to be used by the server. Clear?
Server. Okay. Yes, yes.
Anyone having any more question, guys? So let us proceed and see how we can implement this in our application. So basically, what I'm going to do, I will create one web API application which is going to expose the secure endpoint, which is right where I'm enabling HMAC authentication, and I'm also going to develop one client application that will be a console application, which is going to consume the services with HMAC. So HMAC enabled server application, HMAC enabled client application. So in the client application, first I will show you how to perform the CRUD operation using HMAC. Then I will show you what is reply attack, what are the different ways the attacker can use to send the reply attack, and how HMAC is going to handle that scenario. That is also we are going to discuss. So let us proceed and first create the HMAC server application. So let me go ahead, create one project, Visual Studio, open Visual Studio. So let me go ahead and create one web API project. So let me go ahead and select the projects folder. Then click on the next button, click on the create button. So this should create the ASP.NET Core Web API project. As we are going to store the data in the database, so we are going to use SQL Server as the backend database, and we are going to use Entity Framework Core as the data access technology. So for this purpose, whatever packages are required, those packages we need to install, and we are already know which are the packages we need to install. So let me first install the SQL Server Data Provider package. Then I need to install the migration package, which is basically used to generate and apply the migration. So once this is done, next what we need to do? See, first of all, we need to understand. So where we need to store the client information? What is the client ID? What is the client secret? So those informations we need to store in the database, right? Because database is the most secure place where we need to store this information. So for storing the data, the client information in the database, we need a table. So what are the information that table is going to store? One is the client ID. For each client, we need to generate a unique client ID along with the corresponding client key. And definitely ID is going to be the auto generated. So basically what I'm going to do, I'm going to create a folder, first of all, models in the project root directory, where I will create all my CS class files. So you can create separate folders. But here for time being, to save time, I'm going to create all the CS class file within this models folder. So this is going to be the class for which we will create a database table which is going to store the client information. So what is the client ID secret? That information. See, ID is going to my auto-generated. This client ID you can give any name. For example, mobile client. For example, whatever the company name. Using that company name, you can generate the client. So whatever. This is a meaningful information. Why? Now you might have one question. Sir, this ID is auto-generated unique identity. Then why you are using this one? See, if I'm not providing this user understandable name, how you can identify this client secret keys for which client? For example, there is a client called X company, they are consuming your services. That Y company is also consuming your services. How you can identify this secret is for X company or client Y company? So for that purpose, some user or human understandable client information we need to store. So in this case, this is the client ID. Clear?
Yes.
Clear or not?
Yes.
Right. So what this is client ID and this is going to be its secret key, which is also going to be unique for client. So this you can keep this secret key unique for client or same for all client. That is up to you only. Right? There is no issue. So whichever client secret you use, that is going to be used for generating and validating the token. Then now what I'm going to do is I'm going to provide endpoint to perform database CRUD operation on the employee data. So for a simple example that what I'm going to show you. So what I'm going to do, I'm going to create an employee class, and using this employee class, I'm going to create a table, and on that table, I'm going to perform the database CRUD operation. So very simple class, ID, name, position, and salary. Here, guys, remember, here our main objective is not to perform the database CRUD operation. Here, our main objective to understand how HMAC authentication is going to work, valid data with invalid data, how it is going to handle the reply attack, how to create the middleware which we need, how to register that middleware so that whenever the request comes, it is going to validate whether the right HMAC signature is available or not. If available, it is valid or not. So that is what we need to understand. Instead of keep focusing on this simple fraud operation, our focus should be on HMAC, not on this simple fraud operation. Next, what I'm going to do, I'm going to create my DB context class, which is the what I can say interface between our code and the database. So whatever database table you want to create, whatever the seed data you want to provide, those you need to configure here. Here I'm creating two tables. One is employees, one is client secret. And here also you can see I'm storing some seed data. I'm storing three client. You can see web client, mobile client, and desktop client. So similarly, you can create X company, Y company, Z company, right? Whoever going to consume your services, simply they are all your client. And here, this is my employee data. So two employees I have created. Later on, I will show you how to perform the database crowd operation on this employee data. So this is going to be my DB context class. Next, what I need to do, I need to store the connection string in the offsettings.json file, as well as I'm going to add a flag. So first of all, this is my ready connection string, which is going to generate. Let me give the database name as HMAC So this is the database which I want to create. And this enable HMAC true. Basically, sometimes what happens in production also, we need to enable and disable the HMAC. Sometimes, right, most of the time, 99% of time, HMAC must be enabled on the production. Sometimes to test whether functionality is working as expected or not. Right? In that case, what we need to do, we need to enable HMAC or you can disable. So this is a flag which will tell whether to check HMAC validation or not globally. Right? So if this value is true, then HMAC is enabled. If this value is false, then HMAC is disabled so that HMAC validation will not be happen in the server, right? So this is what I have done till now. Next, what I need to do now, whenever the client request received, right? Whenever the client request received, you can see that header contains the client ID. So based on the client ID, first of all, we need to check whether any client exists or not. If it exists, then what is its corresponding secret key? Why we are going to fetch this information? Because first of all, we need to ensure the client is valid. Second thing, what is the secret key? Because that secret key we need to use to regenerate the HMAC code, right? So for that purpose, we need to create one service class. That service class will having one method. That method will take the client ID. If the client ID exists, then it will return that corresponding client information. So for this purpose, what I'm going to do, I'm going to create a class file, that client secret service class, and this class is going to have one method, and that method is going to retrieve the client information based on the client ID. So here you can see I'm injecting my DB context using the DB context, right? I'm fetching the client secret data. I'm using it as node tracking to improve the performance, and whatever the client ID the user is provided, that client specific information I'm retrieving, right? So in this case, right, in this case, do I need, who is on mute? Who is Rafi? Okay, fine. So now you can see. So do I need all the client information? No, not required. So what information I need? I only need the client secret. If the client ID is valid, then what is the corresponding client secret? If the client is not or a client is invalid, definitely it is going to return null. So in this case, we are only going to return the client secret. Clear? Clear or
Yes.
not?
Yes.
Till now.
Yes.
Okay, fine. Now, once this is done, next is what? Next is what means the actual logic that what we need to implement. So first of all, what we need to do, guys, remember, there are two things. One is filter, another one is middleware. So when filter is going to execute, when middleware is going to execute, filter is nothing but your MVC pipeline. Middleware is nothing but your request processing pipeline. So before reaching the MVC pipeline, we need to check whether the request is valid or not. So that is the reason why what we need to do, we need to create a custom middleware component which is going to validate the HMAC authentication. So what exactly this middleware is going to do? It will check if HMAC is enabled. Where it will check? So it will go to the app settings.json file. It will check whether this HMAC enable HMAC value is true or false. If it is false, then it will not do anything else. Simply it will call the next middleware component. If HMAC is enabled, then what we need to do? We need to validate the presence and structure of the HMAC header. So instead of saying HMAC authorization header, better to say HMAC header, right? So because in this case, you can give any name to this header. For example, you can give HMAC header, right? Any name you can give. Authorization you can also give. HMAC header you can give. So whatever header you specify, as server you need to tell to the client what should be the header. So that header we need to check whether that header is present or not in the HTTP request, right? If the header is present, then what we need to do? From the header, we need to fetch what is the client ID, what is the HMAC code, what is the nonce, and what is the timestamp. So these four information we need to fetch. What is the HMAC token, nonce, timestamp, and the client ID. So whatever the timestamp and nonce the user is specified, we need to verify whether they are valid or not. For example, our requirement is that once the client send a request, in the next 1 minute or 2 minutes, that timestamp is valid. For example, currently 21:27. So if the request is initiated at 21:27, and if we are assuming that request valid is for 2 minutes, then we can check whether that timestamp is expired or not. That is 21:29. That is still that time that the timestamp is valid. But if the same request is coming after 5 minutes, then that timestamp will ensure that this request is invalid. Similarly, nonce means what? Now, within the 5 minutes time period or 2 minutes, whatever you set, within the same time period, if the same nonce value comes to the server, then it will consider this is invalid. If this is not right, if you are not understanding what is the use of timestamp and the nonce uniqueness at this point of time, don't worry. I will show you practically what we mean by this reply attack and how this attack is going to be handled by the server. So once this timestamp and nonce are valid, then what exactly the server is going to do? It will use the same HMAC logic, same hashing algorithm, using the same secret key to generate the HMAC. So once the HMAC is generated, then it can decide whether to accept the request or to reject the request. If the HMAC which is sent by the client and the HMAC which is generated by the server, both are same, means the request is valid, it will proceed. Otherwise, it will reject the request. So let us proceed and see how we can do this in our application. So let me go ahead and create a class file. So this is the most important class file. So please try to observe this class file very carefully. Okay. Let us try to understand. First of all, right, what is the next delegate? Next delegate is nothing but the next middleware component which is registered in the request processing pipeline that will be executed. What is the use of a memory cache? To implement right in memory caching, right? To implement memory caching, we are going to use memory cache. Why we need to use memory cache? I will show you in some time. And this is I configuration. So why you need I configuration instance? Because I need to read this enable HMAC value. So these are the three things, and this nonce expiry. So basically, we are setting that the nonce will be expired right in 5 minutes. For example, whenever the client send a request, we'll fetch the nonce value from the request. We'll store that nonce value in the memory cache for 5 minutes. So within the 5 minutes, if I'm getting the same nonce value, then it will consider as an invalid request. After 5 minutes, that will be deleted from the memory cache, so it will be considered as a valid. So we'll see that practically. So then using the constructor, we are initializing these three instances. Then this is the invoke method, which is going to be invoked automatically when we register this middleware component into the request processing pipeline. So what is the first step? First step, we need to check if HMAC is enabled. How we can do this? Check this enable HMAC key value is true or false. If this value is true, that is fine. If it returns false, we are using the not operator. In that case, what exactly it is going to do? It is going to invoke the next middleware component, and once the next middleware component is executed at the time of returning, It will not do anything. From here, it will return. If HMAC is enabled, then we need to proceed with the HMAC validation process. So now let's assume we are telling to the server, you can pass the HMAC, right, what I can say, HMAC token using a header called authorization. So in the authorization header, please send the HMAC signature. So this signature, the client need to send using the authorization header, right? So any header, any name you can provide. It is not specific that authorization, but you can give any name, right? Then we need to check whether that header is present or not. If present, then fetch that header value to this author header variable. If this header is missing, then what I need to do? I need to return unauthorized. Clear till now? Clear or not?
But Pranaya, in like usually we pass the bearer token in authorization, right?
That is the reason why I'm saying you can give any name. HMAC header. Right?
And we can pass both, right?
Yeah,
HMAC as well as
that's fine. So that authorization token what you are using, that purpose is different. That is going to check whether the client is valid, whether the client has valid permission to access the resources or not. So this
yes,
HMAC is basically going to check whether the request is being tampered by someone in the middle or not,
middle or not. Okay, got it.
right? And that is what I'm saying. Any name you can give. If you are using authorization header, you can give HMAC header. For example, let's proceed with this HMAC header. Clear?
Yes.
Right? So now once the HMAC header is there, right? So we'll face the, if it is not available, we'll return from there saying this one. Now if the authorization header or the HMAC header is present, but it is not start with this HMAC word. So basically, it should start with this string HMAC. If it is not start with this string HMAC, means it is a invalid header value. So if it is not start with this one, means it is invalid. So we need to return the 401 unauthorized. If it starts with HMAC, then what we need to do? Then we need to split the corresponding value into 4 parts. So first one is this one. This is the pipe symbol. Second one is this one, pipe symbol. Third and this one. So basically this string we need to split based on the pipe symbol, and it will give me one array of index position 0 to 3. Right. So that is what I'm doing. So this is authorization header, the substring H space. So after this one, so what is the length? That what I am specifying, this length it will skip, and then if any space are there, that will be trimmed and it will split by the rate what I can say pipe symbol. So basically what exactly it is going to do, it will skip this part and then it will take this string, any space is there before and after, that will be trimmed, and then based on this pipe symbol, it will split this one array. So that array, what it is going to generate it, that array is going to create it with the index position from 0, 1, 2, and 3. 0th position will store the client ID. First position will to store the HMAC token. Second is going to be nonce, and the third one is going to be timestamp. Clear? Clear
Yes.
or not? Right?
Yes.
So if the
Yes,
length
sir.
is not equals to 4, I mean that array what exactly it is generated, if that array length is not equals to 4, means it is invalid. So it should have the length equals to 4. So first, second, third, fourth, that length must be 4. So if everything is valid, then what we need to do, we need to extract the client ID, HMAC token, nonce, and the timestamp. How? Based on the index position, this is my array. The 0th index position will give me the client ID. First index position will give me the token. Similarly, nonce and the timestamp. So till now, anyone having any query? Till now, anyone having any query? Okay. Now, so once we have done this, right? Next, what we need to do, based on the client ID, what I need to do, I need to use this client service method to get the client secret. But this service class, I cannot inject here. As I have already discussed many times, we cannot inject any services, right? Any services, guys, remember, whenever we are registering this into request processing pipeline, So it will be registered as a singleton service. And this client service, as it is dealing with the database, so it is going to be a scoped service. So on a singleton constructor, you cannot inject a instance, you cannot inject a scoped instance. So that is not possible. So we cannot create a variable of client service. You cannot inject that service instance here. Why? Because by default, the middleware is going to be registered as a singleton service, and this client service, as it is dealing with the database, so it is going to be a scoped service. So that is not possible. So if that is not possible, then what I can do is I can request the dependency injection container to give me the client secret service instance. How? The context dot request services dot get required service. And what is the class name? This one, client service, client secret service. So that service instance, I'm requesting the dependency injection container. Hey, Mr. Container, can you please provide the instance of this class? So that instance you will get here. So once you got this client service instance, then using that instance, you can call this method by passing the client ID, which you already fetched from the HMAC token. If this method, once you call, then it will return me secret key. And here that secret key, if available, that secret key will return. Otherwise, you can see it is a nullable type, so it will return null. If this secret key is null, means that client ID is invalid. So in that case, we need to return this invalid client ID. Right? If the secret key is available, then what we need to do? Then we need to proceed and check the timestamp. Right? So whatever the timestamp user is specified, so this is going to be some kind of an integer value, right? A big, or you can say long value, which is similar to a integer. So that value we need to pass, right? If that timestamp, whatever the user is provided, that what we need to convert into long type. And if it is convertible, that is fine. Otherwise, invalid timestamp. So that timestamp, what you specify, that should and must be a type of a long. If it is other type, then this validation, this conversion will fail. In that case, it is going to return this invalid timestamp. Clear? Clear on. So this timestamp, whatever the epoch timestamp we are talking, this is going to be integer type of a value. So once this is done, then what I need to do, I need to generate the current rate. Whatever, right? Based on the timestamp, we need to convert that to UTC date time. So that timestamp we got. So from unique timestamp to UTC date time. So we are converting that to whatever the timestamp, based on the timestamp, what is the time and what is the current time. So and then what we need to do, we need to check the current time minus request time should not be greater than 5 minutes. For example, what exactly it means? It means, right? For example, let's assume this gives me a value of 21. So according to my time, 39. Let's assume 38 or 35. And this is going to be 21, 39. So 34, 39. So now what exactly it is going to do? It will use this time minus this time. So how many difference are there in minute? 39, 35. So 4. So 4 is greater than 5. Yes or no?
No.
No. That means this condition will not satisfy, so it will proceed. Let's assume the request is initiated as 21:30 and current time is this one. So what is the difference in minute? 21:39, 21:30, so 9. 9 is greater than 5.
Yes.
So that means it is an invalid request. So this timestamp, what we are using, right? Here we are setting this to 5 minutes. You can set this to 2 minutes, 1 minute, 3 minutes as per your requirement. So what is the most important thing of this timestamp in timestamp is to verify whether the request is coming within a specific time period. If that request is coming outside of that time period, then we need to consider this as an invalid request. So within 5 minutes, once the user initiates the request, within 5 minutes, if that request is received by the server, then we can consider this request as a valid request, else it is going to be an invalid request. So why we are using this? To avoid the reply attack. So what do you mean by reply attack? See, you send the request, right? And that request is served by the server. Someone copied that request, same epoch time, same data, same nonce, same request time, everything is same. And after 5 minutes, that user is going to send the request again. After 5 minutes, if the user sending the same nonce, same HMAC, same timestamp, same request body, then is this method is going to consider that request as invalid request? Yes or no?
Yes.
Right? Why? Because that the timestamp will not match here. That request is initiated at 12:30 and currently it is 12:39. So 9 minutes is there. That means it is a reply attack. So that for that to avoid, so to avoid the reply attack, we are using that means one request is going to be valid for a specific time period. And here you can set 5 minutes, 2 minutes, 3 minutes. It is up to you only. Clear? After that time period, if the same request comes, then it will consider this request as an invalid request. Clear, guys? Yes or no?
Yes. Yes.
Right. Now, guys, tell me if the request is right. If the hacker sending the request after 5 minutes, it will consider that request as an invalid request. But if the request is comes within time period within 5 minutes, before 5 minutes, then what will happen? Similarly, current is 242. So we initiate this request as 1240. Current is 42. So in 1140, this request is solved. That is fine. Again, that request is sent at 43. Right, right, 40, and current time is this one. The request is solved. Again, the same request is sent by the server and current time is 43. So 43 minus 40, that is 3 minutes. Again, this condition is going to be false. So is that scenario is going to be handled by the timestamp? So timestamp can only handle when the request is outside that time period. If the same request or the reply attack is done by the hacker within the right before that time period, then that is not going to be handled by this timestamp. So before 5 minutes means he will not handle that scenario. Am I right?
Yes, sir. Yeah.
After 5 minutes you will handle, but before 5 minutes the timestamp will not handle that reply attack. So to handle that scenario within the time period, what we are going to use? We are going to use the nonce key. So based on the client ID, so we are already getting the client ID, and whatever the nonce the user is specified. So this is the nonce value. So by taking these two into consideration, we are generating a key, and that key we are checking whether it is available in the memory cache. If it is available in the memory cache, we consider this as an invalid request. If it is not available in the memory cache, then we are storing that key in the memory with a value to true. Whatever, see, this value doesn't matter here. Anything you can store, and that nonce expiry is going to be 5 minutes. Right? So now you can consider. Now the interesting thing is that, see, after 5 minutes, if the request comes, this will handle that scenario that it is a reply attack. Before 5 minutes, if the same request comes, then does this nonce key is already stored in the cache?
Yeah.
Yes or no?
Yes.
Because this definitely it will be there in the cache. And how long it will be there in the cache? For 5 minutes. After 5 minutes, if the request come, this timestamp will handle that scenario. Before 5 minutes means this nonce key will handle that scenario. So along with this timestamp and nonce, we can handle the reply attack. So I will show you this thing practically, right? So now if the timestamp is valid and if the nonce is valid, then what I need to do? We need to check what is the request method. So context dot request dot method. If it is a post method or put method, then in that case, in the case of a post and put, we might be have the request body. So that body is also needs to be used to generate the HMAC. So for that purpose, what we need to do, we need to read the request body. So here for validating the HMAC, we are reading the request body, and at the time of a model binding, again the request body is going to be read. So two times we are going to read, and we have already discussed. If you want to read the request body multiple times, then that what you need to enable. So by default, it will allow only to read once. Then as in our scenario, we are going to read multiple times. So we need to call this a context.request.enable buffering. So that here we'll read the request body. The downstream middleware component, right? They can also read the request body. So then what I need to do, I need to create the reader object. So where we need to pass the request body. And then using the reader object, we can read the request body from the starting to end. And that request body we are going to store in a string variable, right? And then we can set the position to 0 so that the downstream server, the other middleware component, they can also read the request body from the first position. So this is nothing but checking the request method as post or put. If post and put, then we are reading the request body and storing that request body in this request body variable. Clear? Yes or no? Is that clear, guys? Is clear or not?
Yes.
Same. Okay. So now next what we need to do, we need to validate the token. So we have already the token. You can see we are having this client ID, token, nonce, timestamp. This 4 information is there, and here we are having this request body, right? So this 5 information is there. So we are passing the token, nonce, timestamp, request body, and secret key. This secret key we are already getting right here. By calling this method, we are getting the secret key. So client ID we don't need to pass. Instead of a client ID, we are going to pass the secret key. So the token validation method, we are passing the token, we are passing the nonce, we are passing the timestamp, we are passing the secret key. So again, we are passing the request body. And along with this, right, we also need to know what is the method type and what is the request path, which are also required for generating the HTML. That is the request. That is the reason why we are passing the context.request. This context.request object, that request object, going to give me what is the request method, what is the request path, right? So let us see how we can do. So all these things we are passing to this private variable. So here you can see it is taking the token, nonce, timestamp, request body, as well as the secret key. So what is the path? Path I can achieve by calling the path code. Request.path, it is going to give me the path. Path is nothing but the endpoint URL. Suppose employee slash get all. So this is nothing but your request path. So that is what we need to fetch. Then right, we need to prepare our request content. So for preparing the request content, what are the information required? Now first one is requested method. Whatever the request method, post, put, patch, get, right, whatever. So that what we need to specify in the uppercase. This logic is very, very important. The logic what you are applying here, the same logic needs to be used by the client application. Then whatever the path, that what we need to convert into uppercase. Whatever the nonce we are getting from the HMAC header, and what is the timestamp we are getting from the HMAC header. So all these things we have specified here. Then what we are doing, now we are checking if the request method is post or request method is put. Then also we are going to append the request body. So this request body is only going to be added to this request content when the request method is post or put, right? Once this is done, then what we need to do, we need to convert this request content to byte array, as well as we need to convert the secret key, right, that client secret key to byte array. So these two things we need to convert into byte array. So here I'm using this get byte method, passing the secret key, and here also I'm passing the secret key. Sorry, request content, I'm getting the byte array. So once you got the byte array, then what you need to do, you need to create an instance of a HMAC. So while creating the HMAC instance, we need to provide the secret byte array. So once you have the HMAC instance, right? Once you create the HMAC instance, then you can compute the hash. And while computing the hash, you need to pass the request bytes. I mean the request content byte array. So which will return me the computed hash. So this hash we need to convert into base 64 string format. And once the string is generated, this string we need to compare with the incoming string. So if both the tokens are matched, that means request is valid, otherwise it is invalid. So here we will return true or false. If it return false, we are using this not operator. That means it is invalid token. If it return true, then it will call the next middleware call. Clear? Clear,
sir.
guys?
Yeah, here how to generate the secret key?
So how to generate the secret key? So that we have already stored here, na, in the database.
Yeah, that secret can be anything, or it needs to be generated based on any
Yeah,
format.
right?
Anything.
So it can be anything. And it
Mhm.
must be unique value.
Okay.
Okay. Right. And I have already, right, in my previous sessions, I have already told how to generate the client secret, right? What is the best way to generate the secret? Now, so once we have done this, then what is the next step? Next step, we need to register the DP context. We need to register the middleware component. We need to register the services into the request processing pipeline. So let me go ahead and modify this thing. So first of all, I'm disabling the camel case naming convention. You can see I'm not using any camel case. So whatever the property name, that what I want to keep as it is. Then I'm registering my HTTP DP, I mean DP context class. Here I'm using SQL Server. I'm getting the connection string from the offsetting stat.json file. Here I'm using the memory cache because in the HMAC middleware, you can see I'm using this memory cache. For that purpose, you need to enable the service. And here I'm registering the client service as a scoped service. Why I'm using scoped service? Because it is dealing with the database. And then I'm registering my HTTP middleware before the authorization middleware. Before authorization happening, we need to ensure the request is valid. It is not tampered by someone in the middle. Clear?
Yes.
Clear, guys? Okay. Now what I need to do, I need to create my controller, which is going to expose the endpoint, which needs to be consumed by the client. So create a controller, API, empty controller, and right, I'm creating the employees controller. Here, I'm going to provide the endpoint to perform the database CRUD operations, right, on the employee entity. So this is very simple. I'm not going to keep focus on the logic here, context object, using this employees dot to list method to retrieve all the employees. This will retrieve the employee based on the employee ID. This will create a new employee. This will update an existing employee. This will delete an existing employee. So these are the 5 endpoints. What is going to be consumed by the client applications, right? So once this is done, then we need to generate the migration file. So how to generate the migration file? So before generating the migration file, let me build the solution. Okay. So build succeeded. Now go ahead and generate the uh, migration file, add migration mig1. Then we need to update the database. Okay, so this is done. Now, what is the database name we provided? HMAC DB. So we should have the HMAC DB here. So let me refresh this one. So this is going to my HMAC DB. So whatever the data we have provided for the client secret and this client ID, so all this information are there. Now with this, our client application is done. Now what I'm going to do is I'm going to create the, sorry, this is server application. We have completed the server application. Now we are going to develop the client application. So this time I'm going to use a console application as the client application and using HTTP client object, right? HTTP client class. I'm going to show you how you can consume these services. Guys, remember the way I'm consuming the services is common. Common means whatever type of application, .NET application you take into consideration, whether it is a web service, right, web API application consuming other web services, whether it is a MVC application, desktop application, console application, ledger application, ledger pages application, whatever type of applications you take into consideration, the logic is going to be same. The C# code, whatever I'm going to show here, the C# code is going to be same. So what I'm going to do is I'm going to create a simple console application. First, I will show you, first of all, I will show you how to consume the services without having any kind of, what I can say, error. Then I will show you how you can simulate the reply attack. So let me go ahead and create the console application. So this should create the console application with the program class. So this is my console application. So in this application, first of all, what I'm going to do is I'm going to generate one helper class. That helper class is going to have two methods. One method to generate the HMAC token, another method to send the HTTP request, right? So instead of writing the same logic again and again at multiple places, so what I'm going to do, I'm going to write the logic inside a helper class. So this helper class is going to contain two method. One method is to generate the HMAC token at the client side. Another method is to send the HTTP request. See, for generating the HMAC token, what are the data required? So what is the method? HTTP method, get, post, put, patch, delete. What is the request path? What is the client ID? What is the client secret? And what is the request body? So request body is optional. So client ID and client secret. So using this secret key, we will generate the HMAC, and this client ID we need to pass as part of the HMAC header. So that is what we need to remember. So nonce, first of all, I'm generating the nonce. Nonce is nothing but, you can see it is a GOID. GOID means a unique identifier for each request. Every time you generate a HMAC token, it will generate a new nonce and it will generate a timestamp value. So this timestamp, it is nothing but your epoch timestamp, or you can say unique timestamp. So a integer number it is going to generate it, and that integer number is going to be calculated based on the 1/1/1970 till to right to current time. How many seconds are there? Accordingly, it will generate this timestamp value. Then what I need to do, I need to use the same logic, right? Same logic in the sense, if you look at here, whatever the logic I have written, so the same logic I have to write. So first I need to add the method, then path, then nonce, then timestamp, and then the request body. The same logic I have written here. So first method, then path, then nonce, then timestamp. Then I need to check what is the method type. If it is post or put, then I need to append the request body similar to this one. Then I need to convert the secret key and request content to byte array. The similar thing I'm doing here, converting the secret key and the request content to byte array. Then what I'm doing, I'm creating the HMAC object, calculating the hash, converting that hash into base 64, and then comparing here. So instead of comparing, we need to generate the HMAC token here. First, create the HMAC object, then compute the hash, convert that hash into base 64 format, and then prepare the HMAC header value. So that HMAC header is going to contain HMAC space, what is the client ID, what is the token, nonce, and the timestamp. So here we have generated the token. So this is the client ID we are receiving as an input. So this is my generated token, and we are receiving nonce and a right timestamp. So not receiving, we are generating nonce and a timestamp for each request, and that's what I'm passing here. So this is going to be the value of my HMAC header. Clear?
Yes.
Right now. Now this is my send request async method. So this method will be used to send the HTTP request to the client. So instead of writing the logic again and again, so what I'm doing here, I'm writing the logic here only once. See how we are going to do. So from my application, whenever I want to send any request, I need to call this method. So here it is taking the HTTP client. So what is the HTTP method? So using this client instance, I can consume the services. HTTP method, which can be get, put and delete. What is the base URL? What is the endpoint? So this endpoint is nothing but you can consider /employee/all, right? So this is the client ID. This is the client secret and data. So these are the information that needs to be passed when right going to consume the services. So for example, if you want to consume this service, right? What is that service? Employee controller. So in the employee controller, this is the endpoint API employee. So that API employee will be here. What is the base URL? Base URL is nothing but this one. So run the application. So this is nothing but your base URL. So this is base URL. This is my endpoint URL. So these two things is clear. Base URL, endpoint URL, client ID we have already So client ID and client secret will get from the server. If it is a post or a put request, the data will be there. Then what I need to do, right? I need to check whether the data is not null or null. If data is not null, then we need to convert or we need to serialize the data into JSON format. Otherwise, we need to pass a MP. So this is going to my request body. Then what I need to do, I need to call this generate token method, which will return me the HMAC token. So what I need to do now here, I need to call this method dot method. I mean, whether it is a get method post, that what I can access using this HTTP method. Then what is the endpoint URL API slash right? So this is nothing but your URL that value need to pass API slash employees, right? Then what is the client ID, client secret, and the request body. So this is the data what I need to pass to the generate. So this will return me the token. So once I receive the token, then I need to create an instance of right, what I can say, this HTTP request message. So to this message, you need to specify whether it is a get method or post method. That method you need to pass. The second parameter is nothing but your URL. So what is the base URL? And what is the endpoint URL, that what you need to merge, that is going to be the URL, and the body is optional. So if it is a post request or put request, then you can check if the request body is null or empty. If it is not null or empty, then you can specify the request body and what type of a data is this, whether it is a application slash JSON data or application slash XML data. If request body is null, then you need to pass null. So once this is done, next what I need to do, I need to add the header. So what header we need to add here? So we need to have HMAC header here, right? So we need to add this HMAC header and the value is going to be HMAC and whatever the token we received from this generate token method, right? And then we need to call the send async method by passing this request message. So this will invoke, and once it invoke, it will return one HTTP response message. That response message we are not checking here whether it is completed successfully, whether it is completed with error. That will be handled by the caller of this method. So these are the two helper method we have created. One method will send the HTTP request to the server, and that method will internally use this generate HTML, generate HMAC token method to generate the HMAC. Clear? Clear, guys? Okay. Now let us proceed and understand how we can consume or how we can perform the database CRUD operation successfully. So success scenario we are going to test first. So first of all, what is the client? So whichever client information you want to use, I want to use this desktop client. No, I want to use this mobile app client. Okay, any client you can take into consideration. Let me give this mobile app client. And what is the corresponding secret? That what I need to start here. Then second thing is what is the base URL. So on which port number your application is running? 7293. So that what we need to specify here. So this is my HTTP client. So by default, the duration is 100 seconds. Within 100 seconds, if you are not getting the response from the client, it will be throws timeout exception. Here we are increasing that duration to 5. Why? Because I want to debug sometimes, right? I want to explain so that 100-second time period might be expired, right? So that is the reason why. If you want to increase the time period, then you can also increase like this. So you have to set the timeout. So then I want to create a new employee. What is the what are the things you need to do? Right, you guys remember here I have set three things: client ID, client secret, this URL. So this is my employee object which I want to create. And for this one, right, what is the endpoint URL? Endpoint URL is API employee and the method is going to be post. So that is what I'm doing here. So what is the client? Yes, this is the client object what I have created here. That's what I'm passing. What is the method type? Post. What is the base URL? Base URL is this one. What is the endpoint URL? Endpoint URL is this one. So client ID. Then I'm passing the client ID, client secret, and this is the employee data. That what I want to create. So here I will get the HTTP response message, and if each success status code, if it returns true, That means it request completed successfully. So whatever response I got from the client as a server, that what I am printing here, saying that post request created successfully. If there is some error, then what is the status code and what is the error region, that what I am logging. Similarly, I want to get the data. For that purpose, this is my endpoint URL. Method is get, base URL is already set, and here I don't need to pass the request body. Same thing here, if the completed successfully, whatever the response I'm getting, that what I'm printing, otherwise I'm logging the error details. Similarly, right, I want to paste the employee by ID. So employee ID one information I want to retrieve, I'm doing the same thing. So base URL, method type is get, and here I'm specifying that API employees and whatever the employee ID. So if you look at this get by ID method, this is the endpoint URL, and that is what I am specifying here, that employee ID. Now the logic is going to be same. If completed successfully, this one. If it return not found, then this one. If it is not successfully and not found, then whatever the error message. And similarly, you can perform the update operation. Similarly, you can also perform the delete operations. Clear? Clear, guys? Yes or
Yes.
no? Now, first of all, what you need to do, you need to run the server application, which is already running on. And here, what I'm doing, I'm going to provide some debugger pointer so that I can show you how it is working. So now, let me run the client application. Right. So when the request received, you can see what is the client ID. We'll get method post first this one. So it is going to be a post request. So post request is there. Base URL is this one. Endpoint URL is this one. Client is this one. Secret is this one. Data is this JSON object. Right. So first of all, we need to convert that .NET object into JSON. So here you will see the JSON object. Then what I need to do, I need to call this method to generate the token. So now you can see this is going to be a unique value. This is going to my GUID nonce value. And here you can see the timestamp. So it is a integer number 17497463180. So this is going to be my epoch time, which is a integer number. And this number is generated based on the 1/1/1970 till today, how many seconds are there? Accordingly, it will generate this number. So then what I need to do, I need to prepare my request content. Here it is going to be the method name, right method is going to be post. What is the path, API employees, what is the nonce value, and what is the timestamp. So these things I'm taking. Is this a post request or a put request? Yes, it is a post method. Here you can see it is a post method. So this post and this condition satisfy. And here I'm using a OR operator. Anyone is satisfied means it will append that request body into the request content. So now this is going to my request content. So after this, what I need to do, I need to convert that secret key into byte array. So request content into byte array. Then I need to generate that HMAC signature object. Then I need to compute the hash. Again, this hash is going to be byte array. So that hash I need to convert into base 64 string, right? So here you can see this is going to my computed hash. So this is going to be your HMAC token. Now, once the token is generated, what I need to do, I need to return this one. And this is going to be my token signature, HMAC signature. So signature is going to be this one. So here, if you see, this is going to be my signature. So this signature is composed of four things: client ID. This is going to be your HMAC. This will be your right nonce, and this will be your timestamp. So once this is done, right, next what exactly it is going to do? It is going to prepare the request message. Request message is going to contain the method. It's going to contain the URL. It's going to contain the request content. Then it is adding this HMAC header, and then it is going to call the method, right? So in this way, it will execute all the methods, right? So let me continue this one. See, I'm getting right. First one is response created, employee created successfully. Fetching all the employees. You can see first employee This is second employee. This is the newly created third employee. So get by ID. So I'm fetching the employee with ID 1, updating the data, updated successfully, delete successfully. That means it is working as expected. Clear? Clear or no?
Yes.
Okay. Now we need to understand what is Unix time or epoch time. A unique timestamp or epoch time is a numeric representation of time as the number of seconds since January 1, 1970 this UTC. So from this till today, how many number of seconds are there? That is nothing but your epoch time. It is basically represent something like this, right? What is reply attack? A reply attack is when an attacker capture a valid request and resend it to the server to repeat the operation. Since it's, guys, give me 1 minute. Right? Even though the attacker resend the request as HMAC is enabled, so it will consider this as a reply attack. And how to prevent this one? We have already implemented timestamp and a nonce. So let us proceed and understand these things. So what I'm going to do is now I will create a valid post request which is going to be completed successfully. Then I will show you three different ways to reply the attack. So reply attack, identical request, resend, right, with the same HMAC. So along with the same, whatever, the same HMAC I'm going to resend. Again, what I'm going to do, I'm going to modify the request body, but I'm going to use the same HMAC. So same HMAC, but I'm going to modify the body and the reply attack with a different nonce and a timestamp. The same HMAC I'm using, but I'm going to change the nonce and a timestamp. So this is going to be same HMAC, same nonce, same timestamp. Here same HMAC, same nonce, same timestamp, but the request body is going to be modified. Here same HMAC, but nonce and a timestamp are going to be vary. Guys, remember, if you do a small change in the request body, if you do a small change anywhere, either that is part of nonce, timestamp, request body, small change means complete HMAC signature is going to be different, right? So let us understand this thing practically. So let me replace this program class code. Okay. So here what I'm doing here, I'm using the desktop client. So any client you can take into consideration. So what is the IP? IP is 7293. So this will be the, sorry, port number. So this is same thing. So this is my valid HTTP post request. So in this case, this post request is going to be successful. So here I'm calling this generate HMAC method to get the token. I'm not going to use this one. This method I'm not going to use. Why? Because this method is always going to generate a new HMAC token. So which I don't want. So in this case, what I'm going to do, I'm going to call this generate HMAC method, which will return me the token. And this token I'm going to use multiple times to understand, right? To understand the reply attack. So from this token, I can split the part 2 and 3. So part 2 and 3 means the nonce and the timestamp. So index position 0, index position 1, index position 2, index position 3. So index position 2 means nonce, index position 3 means timestamp. So then what I'm doing here, I'm sending this HTTP request. So what is the client method, base URL path, what is the token and the request body. So now this private method, what exactly it is going to do, it is going to generate the HTTP method based on the method based. Then it is going to generate the HTTP request object. So based on the HTTP method and the URL, if method is post or method is put, and if the request body is not null or empty, then it is going to append the right content. And here, what should be the header name? HMAC header, right? So what I'm doing here, I'm adding, removing this HMAC header, and I'm adding. So this removing statement is optional, right? So I'm adding this HMAC header and sending the request. So that means it will send a request. Now, once the request is sent, as this is the first time, so the status is going to be successful. Now, reply attack with identical. So now what I'm doing here, the same request, whatever I'm sending here, the same request I'm again sending here. See, I'm not making any changes. Same client ID, same method, same token, everything is same. Again, I'm sending. So this time it should consider as a reply attack. So now what I'm going to do here, now I'm going to use the same everything, client method, base URL, valid token, everything is going to be same. But this, instead of the original request body, right, the hacker or the attacker, what exactly is doing, he is modifying the body. And with this modified body, if I'm going to pass, then it should return me invalid, right? It should handle the scenario that it is a reply attack. So, right. So now what I'm going to do, I'm going to use the same body, so same request body, same valid token. This time what I'm going to do is I'm going to use different non-signed timestamps. So here you can see again I'm creating the tampered token. So what is the token part 0 and 1? I'm keeping same, that is the client ID and the token. But here I'm using a different nonce and a different timestamp. And this time when I send, I should get the error message that this is a reply attack. So let me run the application and show you whether it is working. See, unauthorized response, nonce has already been used. Nonce has already been used. Invalid HMAC token. Clear? Clear, guys?
Pranay,
Yeah.
can you explain the second option at server side? How it will be, just checking, because I just wanted to understand regarding the nonce value.
Okay. So what I'm doing here, right? I'm putting a debugger pointer here, right? So that first request will be completed successfully. Second request I need to debug, so
Yeah.
that you will get more clarity, right? So where I need to put the debugger pointer, I need to put that debugger here only. Clear, guys?
Yeah.
Right. Okay. So first request will be successful. Why? Because there is no issue. See, it is right. You already see that request. Why I'm getting this? Okay, let me stop this one. Let me stop this one. Okay, let me run the application. So this time we should have this one. Valid post request to succeed. So for the first request, it is working. Right now we need to debug the second request, right? So now when I click here, right, you need to check. First of all, we need to check whether HMAC is enabled. Is this enabled? Yes, true.
Yes.
True means we'll come to the next part. So here we need to check what is the HMAC header. Is this header set by the client? Yes, it is set by the client, so that it will not come inside. Then is that header value start with the HMAC space? Yes, it is start with the HMAC hex, so it will come to the next one. So in this case, after HMAX, how many right? It will get the soft string and then it will
Four.
split that soft based on the pipe symbol. So here we should have the four token part. So here you can see first part, second part, third part, and the fourth part.
Four.
Index position 1, 2, and 3. So again, it will come to this part. So here you can see it is generating, it is fetching the client ID, token, the nonce value, and the timestamp. Then what exactly it is going to do? It is going to get the client service instance, and using this client service instance, it will fetch what is the secret key associated. So once the secret key is retrieved, then it will check, right, whatever the timestamp this is, and right, it will be converted full or not. It should be convertible, so there is no issue. Then what exactly it is going to do? It will convert that timestamp to current requested date time. So what is the current requested date time? 16:48:35. And what is the current time? It is 16:50. That means within that 5-minute time period it is there. So there should not be any issue, right? So it should not come inside the cache block. Now we need to check the nonce. So what is the nonce here? What client ID with this desktop. So in the previous case, this nonce is already stored in the cache.
Okay.
So as
Yeah.
this nonce is already stored in the cache, this time within 5 minutes, this method is going to return me the value or not. So what this method is going to return? True or false?
It will be true.
True means what exactly it is going to return?
Nonce has been already used.
See? That is what I'm
But
getting.
But Pranaya, in case like we have implemented the retry mechanism at the server end, for example, let's suppose
See,
one request came.
if you are re-implementing the retry mechanism, in that case you need to regenerate the HMAC again and again. You cannot use the same HMAC, same nonce and the same timestamp at the time of the re-implementation. So in your case, if you are re-implementing means what? Now you are calling this send request async method multiple times. If you are calling this method multiple times means what? Now this token is going to be generated multiple times. So generating multiple times means what? Each time it is going to generate a new HMAC token.
Okay, but what will happen like if the request from client goes once, but we have applied the retry mechanism at the server end? Like for the first time, let's suppose it was a server issue, it was not able to process the request, but the second time there was a retry implemented, and the second time it tried to process. In that case,
See, I'm not getting. So second time try to process first time server issue means what?
for
See,
example, our
first
yeah,
of all, you just tell me, first of all, when you hit for the first time, is this right? First time means is this middleware executed or not?
let's suppose it executed, but it for
It
any
execute
reason.
means, see, if it executed means you cannot use the same HMAC anymore. See,
Okay.
if this HMAC, if this middleware executed means what? It is already either accept the request or reject the request, because within this middleware we have already written whether to accept the request or reject the request. After this middleware, it will go to the next middle. Next middleware means what? Already that request is accepted by the server, so you cannot use the same HMAC anymore.
Okay.
And that is the reason why, see, if you see how the server will know whether you are the one who is sending the same request or it is the request sent by some hacker. Server have no idea. And that is what we need to handle. Even though you are writing the retry logic, every time you send the request, you have to regenerate the HMAC token. That is right as per the security standard. You should not use the same nonce, same timestamp, and the same right token again and again in your retry logic. You have to regenerate them
Yeah,
because
from client.
server. See,
Yes.
this is when the client and server communication. RESTful means what? Stateless. Stateless
Yeah,
means what? Server have no idea about the client about the previous request. So
previous
when the
request.
it is a brand new or fresh request. Fresh request means I need to, right? What exactly it means? I need to consider it as a new request only. And whether how, right? For example, you are thinking that I'm resending the same request. How does the server will identify whether that request is coming from you or from someone else?
Okay.
Right? That is the reason why only one time. Clear?
Yeah.
And after 5 minutes, I'm getting the timeout exception. Has cancelled exception. Because why I'm getting this exception? Because we have said that within 5 minutes, if the operation not completed, it will cancel. Clear, guys?